In this tutorial, we will be discussing how to use the constant perimeter coil-end path section to make some sort of more interesting custom coils. In order to do that, we'll start by making a custom coil, and then we'll show you how to use first add a cross section, just a rectangle, and then I want to show you how to use path group in combination with the constant perimeter coil-end. Constant perimeter coil-end is something that you see in, for instance, cosine theta coils. There is a video on the cosine theta coil in red on YouTube as well. More information can also be found in this book. But today I'm going to focus on the constant perimeter coil-end, which is basically also described by this equation here. And so in order to do that, I'm going to use the path group that I just added to my custom coil by right-clicking on it, set path, path group. And now in this group I can start adding sections, and I'll start with a straight section. In principle you can add like anything to the path group, but let's work with sections here. This is just a straight rectangular piece of conductor. I'm going to make this a bit longer for the purpose of this video. And the next section I want to add is a super ellipse. The super ellipse is basically the constant perimeter coil-end. And you see already here that it's immediately added to the end of the straight section. And this is a nice way of going over a beam pipe. And for instance, if I add a mesh, like a cylinder mesh, this one I need to rotate a little bit by 90 degrees, such that it is rotation vector, not Z, but X, I guess. Yeah, now it's still in the center, so I'm gonna also do a post offset. Sorry, you have this post offset, which is like a translation in the Z direction. There you go. So basically, if you want to take your, let's make it even longer. If you have, for instance, a beam pipe, then sometimes you would want to go over it. And one way to do it is that you use a constant perimeter coil-end. And that's this super ellipse. And this will draw like half of the complete path. And now what is nice about it, create group mirror, there you go. And I want to translate this one even further. No, but I want to maybe translate this translation in the 50. There you go. If I now, for instance, have two beam pipes and I want to cross over both of them, I could actually do that. And the way to do that is, now I'm sort of at half of this one. And then I'm going to add another straight section to my path group. There you go. So this is how I reach the other side, basically. I'm going to shorten this one. 30, well, let's see. Let's copy this one. And here you see it's continuing, but what I want is not to rotate this constant perimeter coil in the same direction as this one, but I'd like to have basically the reverse of that one. So that's this button. And now I'm going to increase that straight section. There you go. And now I have crossed over both of them. I can copy this straight section one more time. And by finishing this off with these, I basically have two straight sections here and there, and then along the beam pipe another two straight sections, and I have used the constant perimeter coil-end to cross over both beam pipes, for instance. So that's a nice way of applying the super ellipse or the constant perimeter coil-end to a path group. The settings here are roughly the same as the one for the cosine theta settings. So that is in the other video, it's explained here where you have the number of poles, the radius, the phi, and the alpha phi and alpha are explained here. And all these settings, they basically show up here as well. There is a few different ones. For instance, BA. This will actually change the length of the coil end in the axial direction. So you saw that changing. So we're gonna go back. Oh, I think it was 50 or something like that. Yeah, 50. Phi discussed. Beta is the angle of the legs. So that's this angle here. Oh, I can turn it around. This angle here, if it's 0, it's flat. Z theta, adjustment of the angle of the onset of the coil. I'm actually going to remove all these too. This one as well. And this one, to make it a bit more insightful. If I change Z theta, you see that it sort of bends in this direction. So that is the adjustment of the angle at the onset of the coil. So that's over here. Z theta 2 is the adjustment of the angle at the nose of the coil. So that would be at this end. So if I change that, you see this, it's actually in this plane where it's rotating. You see that this cross section is twisting because this angle is being adjusted back to 0 and you get the original. There's also an adjustment of the radius of the nose of the coil, so I can make this higher just in case that's necessary. So this is really sort of a special case of the cosine theta coil. And then there's the arc length. This is a 90 degrees, although we have changed that with the Z theta. This is 90 degrees, so it starts here and goes 90 degrees and then ends here. You could, you could not make it longer. You can make it shorter, but the downside is that this thing becomes crooked. And as it says here in the tooltip, the length of the curved section, which is normally set to 90, to avoid crooked Darboux vectors at the start and the end. And you can see the Darboux vectors by looking at the mesh, toggle mesh. You see, oh, excuse me. You can see here, this one is crossing that one, and that is not allowed. Oh, excuse me. I can remove that mesh. This is what you do. This can happen if you change this by too much. Now it's still okay. Here these two, which are the Darboux vectors, basically the orientation of your cross section with respect to your path. These two are not crossing each other, so then it's okay. So this is a special case of the cosine theta coil, or the constant perimeter coil end, and you can use it to create interesting coils that are not standard in Rat. Bye bye!